Greetings, psychology students. Before we get into the specifics of the role of light, the SCN, and melatonin in the sleep-wake cycle, let's just look at the broader notion of the circadian rhythm. So points of emphasis when you are defining or explaining why sleep is indeed a circadian process is think about what the meaning of the word circadian means around a day. So you're going to emphasize that it's a 24-hour process, that the circadian rhythm is indeed a biological process that regulates both behavior and physiological processes. Now, there are a complex array of internal mechanisms and external factors that influence and direct the circadian sleep-wake cycle. Now, in the VCE course, we focus on the external factors, which we know as zeitgebers. Zeitgebers, or time cues, such as when we eat, light or lack of, activity and temperature, all influence an area of the hypothalamus. Hypothalamus, a key part of the brain that influences gland activity, contains an area that's made up of a few thousand neurons known as the suprachiasmatic nucleus. And it's the suprachiasmatic nucleus that's part of your hypothalamus that basically directs the body clock, the circadian rhythm, along with a variety of other peripheral oscillators which are beyond the scope of the course. So let's go through this step by step in terms of how this mechanism works. So we wake up in the morning and we open up our curtains and we're exposed to the zeitgeber of light, the most powerful zeitgeber. Those light rays reach the back of our eye, our retina, which is step 2, and part of your retina is sensitive to the amount of light in our environment. So it then sends a signal to the SCN, the suprachiasmatic nucleus. Now, what students get wrong here is they say the suprachiasmatic nucleus then will suppress melatonin. Not quite. It will send a signal to the nearby pineal gland, and the pineal gland is getting a message from the SCN, wake up. So therefore, it will suppress the sleep hormone melatonin. And once we do that, then we will start waking up. Now, let's look at this in reverse. Now it's nighttime. We're in a dark environment, step 1. The lack of light reaches the back of our eye, our retina, for step 2. The retina then sends a signal to the SCN, step 3, part of the hypothalamus. And again, be careful of the trap. Do not say that the SCN will release melatonin. It doesn't release or suppress anything. It signals other glands to either up the ante or suppress activity in terms of the release of a variety of hormones. In this case, we're focusing on the PG, the pineal gland. So the pineal gland is getting a signal from the SCN. It's dark. It's time to go to sleep. So pineal gland, do your thing and start releasing the hormone melatonin into the bloodstream so that we can have some night-night.